Find the curvature of the normal section of the helicoid. X equals to u cos of theta, y equals to u sin of theta, z equals to fu plus c theta, where c is a constant and u theta are the parameters. Now solution here: r equals to u cos of v, u sin of v, fu plus cv. So r1 differentiation with respect to u cos of v, u and sin of v, and f dash cv is constant equals to 0. Now r2, the differentiation with respect to v, u as it is cos v's differentiation is minus sin v, u as it is sin v's differentiation cos of v, and first term is constant. Second, cv's differentiation c constant, v's differentiation with respect to v is 1. So r11 differentiation of r1 with respect to u, first two term is 0 because not containing u, and last term is f double dash second derivative with respect to u. And r1's derivative with respect to v, cos of v's differentiation with respect to v is minus sin v, sin v's differentiation is cos of v, and the third term is containing u is equals to 0. Now r2's differentiation with respect to v minus u, sin v's differentiation with respect to v is cos of v, so minus u cos of v, u as it is. Now cos v's differentiation with respect to v is minus sin v, and c is a constant equals to 0. So E equals to r1 dot r1 equals to r1 square, r1 from this sin cos square v plus sin square v plus f dash square cos square v plus sin square v equals to 1. So equals to 1 plus f dash square f r1 dot r2 equals to cos of v sin of v f dash dot minus u sin v, u cos of v, and c cos of v and minus u sin of v equals to minus u sin v cos of v, and again plus sin of v into cos of v, u sin of v of cos of v, plus last term containing f dash and c, product of c into f dash. Now minus u sin of v and cos of v plus u sin of v cos of v cancel out, so gives rise to equals to c f dash. Similarly, g equals to r2 dot r2 equals to r2 square u square sin square v plus u square cos square v plus c square equals to u square sin square v plus cos square v plus c square equals to u square plus c square. H square equals to eg minus f square equals to 1 plus f dash square into u square plus c square minus c square into f dash square equals to u square plus u square f dash square c square plus c square f dash square minus c square f dash square. You c square f dash c square into f dash square cancel out, so equals to u square into 1 plus f dash square plus c square. Now r1 cross r2 equals to ijk cos of v sine of v f dash minus u sine of v cos of v c. So I equals to c sine of v minus u f dash cos of v minus j equals into c cos of v plus minus minus plus u f dash sine of v plus k equals to c u cos square v plus u sine square v. So I into c sine v minus u f cos of v and j into c cos of v plus u f dash sine v. This u square u taking common and cos square v plus sine square v equals to 1, so plus ku, so equals to c sine of v minus u f dash cos v minus c cos of v minus u f dash sine v and u. So n equals to r1 cross r2 upon h, so c minus c sine v minus u f cos of v and minus c cos of v and minus u f dash sine v and u as it is upon h. So L equals to r1 1 dot n equals to 0 0 f double dash dot c sine of v minus u f dash cos of v and c minus c cos of v minus u f dash sine of v u upon h. First two term in dot product in multiplication with the 0 is 0, and third term is equal to u f double dash upon h. Similarly m r1 2 dot n equals to minus sine v cos of v 0 dot c cos of v minus u f dash cos of v minus c cos of v minus u f dash sine v and u upon h. First term minus c sine square v plus minus plus u f dash sine of v into cos of v minus second term cos of v into minus sine minus c cos square v minus u f dash sine v cos of v, and third term containing 0, so dot product equals to 0 upon h equals to minus u f dash sine of v cos of v will cancel out, minus u f dash sine of v and cos of v, and containing this term be taken minus c common, so sine square v plus cos square v upon h equals to minus c upon h. Similarly n equals to r2 2 dot n equals to minus u cos of v minus u sine of v 0 minus c sine of v minus u f dash cos of v minus u cos of v minus u f dash sine of v and u upon h equals to minus u c sine of v cos of v plus u square f dash cos square v plus uc cos of v sin of v plus u square f dash sin square v upon h equals to minus uc f uc cos of v and sin of v will cancel out, and u square f dash taken common, cos square v plus sin square v upon h. Cos square v plus sin square v is equal to 1, so equals to u square f dash upon h. So kn equals to l du square plus m du dv plus n dv square upon e du square plus 2 f du dv plus g dv square equals to u of f double dash, putting the value of l upon h, du square minus 2 into substituting the value of m minus c upon h du dv plus n values u square f dash upon h dv square upon e value 1 plus f dash square du square plus 2 into f's value c f dash du dv plus g's value u square plus c square into dv square, so equals to u f dash f double dash du square minus 2c du dv plus u square f dash dv square upon taken h to the denominator into 1 plus f dash square du square plus 2c f dash du dv plus u square plus c square into dv square.